Okay, in this session, we're going to go ahead and begin on homework exercise number 6 from section 11.8, which deals with expected value. All right, let's go ahead and read the problem. The probabilities and gain or loss for guessing on a standardized test is shown in the table to the right. Suppose that you eliminate one of the possible 6 answers. Modify the 2 probabilities shown by finding the probabilities of guessing correctly and guessing incorrectly under these circumstances. What is the expected point value of a random guess? Is it advantageous to guess under these circumstances? Okay, so what we're going to look at here is notice that these are the probabilities given. However, you are able to eliminate one of the 6 possible answers. You know that's not correct. So, again, if we have our values in L1 and our values in L and our probabilities in L2, we can get the correct answer. Okay. Now, normally to guess correctly, we have 6 values, 1, 6, but we eliminated one of the values, so the probability is going to be 1/5. Now, notice you do get a value of 1. You get your gain is 1. Now, if you guess incorrectly, it stays negative 1/3. But again, remember that you have only 5 different possibilities now. So instead of 5 out of 6 wrong, you have 4 out of 5 wrong. So now these are your new probabilities with respect to eliminating one of the possible 6 answers. So now what we can do is we can go ahead and put this into our calculator, either multiply or put it into a list and go ahead and get our answers. So again, we will put in these different values and get the expected value. So again, on our calculator, if you do it with the list, you can go to your stat key, all right, and we have stat, and we're going to go ahead and hit enter, and L1 and L2, and we're going to go ahead and put in 1. Now, if you have values in L1, L2, like different numbers, remember, you can go ahead and highlight L1, hit clear, don't hit delete, hit enter, and it'll get rid of the values. So now in L1 are the point values. We get 1 point for getting the correct answer, a negative 1 divided by 3. You can put it in as a fraction for getting it wrong. Now what's the probability? Remember, it is now 1 divided by 5 because we eliminated one of the 6 answers. So that's the probability of getting it correct. And getting it wrong is now the other 4 out of 5, or 4 divided by 5, which we know is 0.8. So there are our 2 probabilities with our expected values. So now we can go ahead and go back to stat and go to calculations. And if you have one variable stats, everything's just one variable because it's just a question on a test. So always hit enter for all the expected value problems. And remember, if your calculator has 3 different lines, you put L1 in line 1 for the list, the frequencies in L2, then hit calculate. For a TI-83 or 84, you put in second number 1, and remember, you get second number 1 to get L1, and then a comma, second L2, the comma is above the 7 for the probabilities, hit enter, and now you have a negative value for the expected value. Now, since it's negative, it is not advantageous to guess because you're getting a negative value. If it's positive, it was negative. So now you have, again, you have negative 0.06777. Now, what we probably want to do is 0.066666 is go ahead, and I think we have to put that in as type an integer rounded to 2 decimal places. Okay, so that's good. So it'll be a negative 0.07. Remember, your x bar is your first value the first value is the expected value. So to the nearest 2 decimal places, it's going to be a negative 0.07. We're going to round off the second decimal 6 to a 7 because the third decimal is a 6. Okay, and there's our correct answer. Again, we had a negative, the x bar is the expected value, and negative 0.06666. So to 2 decimal places, we're going to round off here. So then this is a 6, so we would go ahead and make it negative 0.07, which indeed was our correct answer. And again, since the number was negative, we're going to go ahead negative. Then it's expected to lose points, so then it would be not advantageous to guess. If it was positive number, the expected value, then it would be advantageous to guess. Okay? All right, very good. All right, let's look at number 7. A store specializing in mountain bikes is open in one of 2 malls. If the first mall is selected, the store anticipates a profit of $1,050,000 if successful and a yearly loss of $350,000 otherwise. The probability of success is 1/2. If the second mall is selected and it is estimated that the yearly profit will be $700,000 if successful, otherwise the annual loss will be $210,000. The probability of success at the second mall is 3/4. Okay, what is the expected value of the first mall? Okay, first mall, again, we have our L1 and our L2, right? Now, if it's going to be success, then what? Their profit is going to be $1,050,000, and we probably don't want to put in commas when we put it in the calculator. We can't use commas. And the probability of success is 1/2, right? So it's 1/2. The probability, if it's of a loss, is 350,000. So if they're going to lose money or not successful, then it's going to be a negative 350,000. And again, though it's either successful or it's lost. So you subtract 1 minus 1/2, the probability of success, and again, 1 minus 1/2 is 1/2. So both of these probabilities are 1/2. Now this is for mall 1. Okay, now we have to do one at a time. So we're going to go ahead and do mall 1. Okay, so we're going to go ahead and put in, we're going to go to our stat key. Okay, clear. And we're going to go to edit. And again, we've got different values. So we're going to clear out L1 and clear out L2. Okay, the successful is 1,050,000. Okay. And if it's not successful, then it is going to be a negative. They're going to lose $350,000. Each of the now the probability for success was given to be 1/2, right? So 1 divided by 2. And again, the other one, so failure is going to be 1 minus 1/2. You can put that in your calculator. 1 minus 1 divided by 2, and then we know it's 1/2. All right, and then we're going to go back to stat, calculations, always one variable, and we're going to hit L1, comma, L2. If you have a newer version, you're going to put L1 in the first line, L2 in the second, by using second number 1, second number 2. Hit enter. And the expected profit is going to be 350,000. X bar is the first number, always represents the expected profit. Okay? Now, what is the expected profit of the second mall? The second mall is going to be again, L1, L2. We have, if it is successful, it's going to be 700,000. Okay, and otherwise it's going to be a loss of 210,000. So that's negative. Now the success is 3/4. So 3/4 goes here. So the failure, so the otherwise, the loss, the probability will be 1 minus 3/4, which is 4/4 minus 3/4, which we know is 1/4. So the probability here is 1/4. So again, we can go ahead and put in these probabilities, okay, and we get close the ink layer, clear, and we'll go ahead and put stat, edit, and again we've got different values, so we're going to clear out L2 and clear out L1, and the first value, success, is 700,000. All right. The loss is going to be, if it's not successful, a negative 210,000. Remember, the negative is below the 3. Okay. And then the success of the first mole, remember, was 3/4. So you can just go ahead and put 3 divided by 4, or the decimal, 0.75. So the probability of failure is going to be 1 minus the probability of success, which is 1 minus 3/4, or 1/4, right? So there's our two values for the probability of the second mole. So now we go to stat, over to calculations, one variable, and again, second number 1 for L1, comma, second number 2 for L2, and if remember, you just put in L1 for the first line, L2 for the second, and then hit calculate if you have a newer version of the TI-84. And this expected profit is always going to be the first value under one variable stats, X bar, which is 472,500. Okay, so that indeed is the correct answer. So now, which mall should we maximize in order? Which mall should be chosen in order to maximize the expected profit? Well, we don't know for sure, so we can only go by expected value, right? So we're going to take the higher one of the positives, right? So we see that the second mall is 472,500 compared to the first mall, which is only 350. So then definitely the second mall should be the one that should be chosen to maximize profits. Okay, that explains problems, homework exercises 6 and 7 from section 11.8. If you have any questions, send me an email. That concludes this YouTube session on expected value problems 6 and 7. Thank you.